Hi pre-calc class, it's Miss Lauschke here. We did not get those last four functions analyzed, so we need to do 10b, 10c, and 11b and 11c. So let's go ahead and start with 10b, and of course this is a logarithmic function, and the parent function is log base 2 of x. We can see that it has been shifted. So if I follow, like, even if I follow this, oops, excuse me. Let me turn my draw back on. Sorry about that. Even if I follow this point right here, it looks like it's been moved 5 this way, right? Because it started at +1 and now it's at -4. So it's been moved 5 this way and 2 up. Okay, so 5 and 2 are our magic numbers here. That's like our HK. And so what we're going to do, and I'm going to go over here so you can see I have some white space to write. We are going to take our log base 2, I'll just do y equals a times log base 2 of your x, and we said it went to the left 5, so that's +5, and up 2, okay? Because this is x minus a -5, right? So that's why we did +5, and then this is just up 2, +2. And we can put a point in for our function, so I see the point -3, +3. So +3, -3. So 3 equals a times log base 2 of 2 plus 2. Well, log base 2 of 2 is 1, because basically your answer to a logarithm is always the exponent when this is your base and this is your answer. So I have to think, when I see log base 2 of 2, I need to be thinking 2 to what power is 2, right? This is my base right here. 2 to some power is 2. Oh, well, that power is 1. So that's the answer to my logarithm. And so this is going to be 3 equals a times 1 plus 2. I'm going to subtract 2 from both sides. So my a is 1, okay? So that gives me a function of log base 2 of x plus 5 plus 2. And then your domain. Logarithms always have a vertical asymptote, so you can see the vertical asymptote right here. And you can also algebraically take the argument x plus 5 and say, oh, well, that has to be greater than 0. So you know that x has to be greater than -5. So, and you can't ever equal -5 because you can't take a logarithm of a 0 there. So it's going to be a parenthesis, -5 to infinity for your domain. And your range is going to be everything, -infinity to +infinity. You can see that all the y values are being used. So that is your 10b. Now let's look at 10c in the same way. The only thing about 10c is that you can see that there has been a reflection. And it looks like it was a reflection across the x-axis, because you see that it's shooting up like that. See how this one is shooting up? Well, that would have been a reflection about that x-axis here. And so a reflection about the x-axis negates the y, which you can think of as negating in front of the log base 2. That's like your y. So if you had y equals, and you know that it was going to be a negation, you know, you could go like that, or you can just say, you know what, I'm just going to solve. I know my a is going to be negative because I already see it. I'm just going to put my a in there. Log base 2 of, okay, and then we have to look and see what we have here. So when you were, reflecting it, you can see that after the reflection, that this point right here is your top point, because here's going to be the other one and here's going to be the other one. So that top point right here, that's the one that we're looking at. And it's going from being at 1, 0. So going from being at 1, 0, it's going 1, 2, 3, 4 to the left and 2 down. Okay, so 4 left and 2 down gives you an x minus a minus 4, and then 2 down is minus 2. And so we can put a point in. So let's put like the point 0, negative 4. So negative 4 equals a times log base 2 of 0 plus 4 minus 2. Negative 4 equals a times log base 2 of 4 minus 2. So you should be in your think bubble thinking 2 to what power is 4, right? That's base of 2 to some power is 4, and that's going to be the answer to this whole logarithm here. And so since I know that 2 to the second power is 4, that answer is 2, because 2 to the second is 4. So I'm going to add 2. Negative 2 equals 2a. Divide by 2. So our a is just negative 1, okay? Which is what we kind of thought it was, but that's fine. So now we go up here and we say negative log base 2 of, and we said it was x plus 4, and then minus 2. And just to look at, I'm going to erase that and look at, here's our vertical asymptote. Remember, our vertical asymptote can be found by taking this argument and setting it equal to 0, or well, saying that, no, not setting it equal to 0. What in the world? That does give you your vertical asymptote, though. If you set it equal to 0, that's your vertical asymptote. We want our domain, and we know that it has to be greater than 0. So x has to be greater than negative 4. So that makes our domain negative 4 to infinity. And our range is going to be negative infinity to positive infinity. Okay. So now that moves us to number 11b. So this is going to be, this is our greatest integer function, and there's a couple of different ways to look at this, but I noticed that right away, this would have been my original parent function, and it looks like it just got moved over 2 units to the left, so x minus a minus 2, and that's really it. It doesn't look like it's, it's still going from, just one thing here, from negative 4 to negative 3, from negative 3 to negative 2, negative 2 to negative 1, negative 1 to 0. It's still just going one spot. And so this is going to be, because it's minus a minus 2, right? Because it was shifted 2 units to the left. So that's just going to be that. And your domain is everything. And your range, I like to write it as y is an element of the set of integers. Remember the double bar z. I just write a z and then I write another one next to it. That is the integers. That's how you can talk about the integers. And remember what the integers are. Negative 3, negative 2, negative 1. Sorry. 0, 1, 2. So it's all those numbers, all the negatives, 0, and all the positives, but nothing in between. So that's why we're saying that is our range, because you can see that on the y-axis you've got -2, -1, 0, you know, you're skipping everything in between for the y values. And then the next one, now this one is a little bit different. It does have, you know, like it's starting at 0, 0, but look, it extends to 2 values. So this one is a little bit different. It's almost like it's stretching it. So for this one, a good way to think of it as when you have a stretch like that, you think of it as divided, how do I say that? It's a horizontal stretch, because it's being like stretched wide, you know, wider. It was 1 unit and now it's 2. And so that usually is in the form of x over c, where c is your stretch. So since our stretch was 2, this is going to be like x over 2. So 1/2 x, or x over 2, however you want to write it. And I just put a bracket for this, and then I put a line connecting it. So I put a bracket and then I put a line, but I don't know if that's the best way to write it. But we have 1/2 x, our domain, -infinity to +infinity. And our range, again, is just y is an element of the set of integers. So just to make sure that this works, if I put a 1 in, I should get a 0. Because when I put a 1 in, this becomes 1/2. So I'm actually kind of now looking at this and I get 0. I'm now looking, you know, at this function is really 1/2, right? And I get 0. If I put a, let's say a 3 in right here, okay, that's 3/2 over here. If I go to 1.5, I get 1. So that's why when you put a 3 in here, you get 1. Does that make sense? I know these functions at the end, we're going to learn them better coming up. So don't get upset if this doesn't make sense to you right now. It will make sense to you eventually. Thank you so